Assalamualaikum and hello. In this video, we will briefly talk about a wave-related phenomena which happen when the wave overlaps. This is a subtopic in mechanical wave. Before we start, let us recall the previous lecture on mechanical wave. What is a wave? Have you ever seen a wave before? I believe each of you have encountered various types of wave in our life. A common example of mechanical wave is water wave, which can be seen with naked eyes. Do you know other examples of wave? Sound wave, for example, is a longitudinal wave which can travel differently compared to a translational wave like water wave. If we put two sources of wave quite near to each other, what do you think will happen? This action will make us hear a series of loud and soft sounds as we walk. So now, the big question here is what really happens when wave overlaps? Do you have any idea? This video will demonstrate the behavior of wave when overlaps, which produce interference pattern.
I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there.
The next question, what is interference? Interference is defined as the interaction of two or more wave motions. There are two types of interference which are known as constructive interference and disruptive interference. Initially, when two individual waves with nearly the same amplitude moving toward each other, they will overlap. This happens at the same time and at the same space as waves behave differently compared to objects. Objects, on the other hand, cannot occupy the same space and time. Next, the wave overlap, causing the resultant wave to be double the amplitude of the individual wave at the moment they overlap. In other words, they sum up the amplitude of both individual waves. Then, each individual wave or pulse will continue to travel through each other with the same initial amplitude. If two pulses moving towards each other but with different amplitudes of positive A and negative A, the resultant wave will have absolute zero amplitude. Then, they will travel through each other with the initial amplitude. Both constructive and disruptive interference can be explained by using the principle of superposition. By the way, what is the principle of superposition mean? Principle of superposition is defined as whenever two or more waves are traveling in the same region, the resultant displacement at any point is the vector sum of their individual displacement at that point. Can you guess what will happen if we combine the waves? So, if we overlap a set of waves which have the identical amplitude and in the same phase, the summation of these waves will produce a new wave which has double the amplitude of the initial waves. This is what we call as in phase. Can you guess what will happen if the first wave was shifted to the left as much as the pi radian change, and then make it overlap with the second wave? The summation of these two waves in this example, however, will produce a new wave of zero amplitude. This is what we call as antiphase, or also known as out of phase. Let's do some simple quizzes to check your understanding. Here is the question 1. Please choose the correct answer. If your answer is B, then it is correct. This is because the phenomena of wave interaction is called as interference, while the principle that we use to explain the phenomena is superposition principle. Here is the second quiz. Please fill in the blank. So the answer is, when a resultant wave has greater amplitude than the individual wave, this is called constructive interference. When a resultant wave has smaller amplitude than the individual wave, this is called destructive interference. Hope you enjoyed this video. Thanks for watching. Have a nice day. Wassalam.